Well, this is Unit 70 and our Part 1. And 16 factorial. Now, when you go to pages 458 and 459, they explain factorial, but factorial is, say, 3 factorial. That's 3 times 2 times 1. 4 factorial. 4 times 3 times 2 times 1, and so on. So 16 factorial would be 16 times 15, and so on, all the way down to 1. And so now 16 factorial is 16 times 15 times 14, and on 2 times 1. By the way, 2 times 1 is 2, so oftentimes I'll just skip the 1. And when we carry out that product, we get 2.0923 times 10 to the 13th, and that's selection C. And again, pages 458, 459. Now for 2, we're going to use factorials, a quotient of factorials. So 10 factorial is 10 times 9 times 8 times 7 times 6 factorial. I'm going to stop right there with the 6 factorial. And then 4 factorial is 1 times 2 times 3 times 4. And 10 minus 4 factorial, that is 6 factorial. So watch this. The 6 factorials divide out. Also, 2 times 4 is 8, so the 8's divide out. And 3 goes into 9 3 times. So now we have 10 times 3 times 7. And 3 times 7 is 21, times 10 is 210, and so our selection is C. And you can see examples of this on page 462. Now for 3, it says a Morse code. In Morse code, each symbol is either a dot or a dash. How many sequences of 12 symbols are possible? Well, we only have two options, either a dot or a dash. So we have 2 selections, and we can pick one of 2, and we're going to make a 12-symbol code. So we have 2 choices for the first, 2 choices for the second, 2 choices for the third, and so on, all the way up to 2 choices for the 12th. So that's 2 to the 12th. Which equals 4096, and that's selection D. And you'll see that on page, an explanation on page 457. Now, for question 4, we're dealing with permutations, and they're on page 460. Now, permutations can be written this way. N, the number of choices. P, for permutations, choose R, the number of we're actually going to choose, the number of possibilities, and R is the number we're actually going to choose. And in permutations, arrangements, we're talking about arrangements where order is important. For example, if you're going to choose a committee of president, vice president, and secretary, the arrangement, the order is important. And the formula for that is NPR equals n factorial over the difference between n and r and that factorial. So 7p choose 5 is going to be 7 factorial, and 7 minus 5 factorial is 7 minus 5 is 2, and 2 factorial, by the way, is just 2 times 1, which is 2. So we have 7 times 6 times 5 times 4 times 3 times 2, and the 2's divide out, and when we carry out that product, we get 2520, which is selection B, and you'll see that, as I said, on page 460. Now for the next one, we're talking combinations, and this is the case where order is not important. For example, if you're going to choose a committee of 3 people, nobody has a title, so it doesn't matter which one's first, second, or third. And so you'll see combinations on page 462, and the formula for that is n choose r, and that's n factorial, and in the denominator n minus r, the factorial of that, times r factorial. So we've got 23 choose 6. So that's 23 factorial over 17. Now 6 from 23 is 17, so that's 17 factorial times 6 factorial. So 23 factorial is 23 times 22 times 21 times 20 times 19 times 18 times 17 factorial. I'm going to leave that in that form, and notice these 17 factorials divide out. Now 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, but 1 times 2 is 2, so I'm just going to leave the 1 out. Now, 5 times 4 is 20, so we can cross out the 20s. 6 times 3 is 18, so the 18s divide out, and 2 goes into 22 11 times. So now we have 23 times 11 times 21 times 19. And when we carry out that product, we get 100,947, and our choice is D. And we'll go on to the next part.